Hello, so I wanted to just do another video with more practice with balancing redox equations. I just want my pen to work here. There we go. So when we're taking a look at balancing with redox, there's a few things we'll just have to go over first. One of them being that when you are balancing, you must use oxidation numbers. You cannot balance by inspection. So inspection just means how you would normally balance, like look at how many you have on the product side, how many is on the reactant side, and make it the same. We can't do that, and that's because reactions is all about the exchange of electrons if you are that redox reaction. So everything is based on that. So to do that, these are our steps. You assign your oxidation numbers. In the process, you will identify your OA and your RA, and then you would want to add a coefficient in front of the species so that we can balance out those electrons. Once we've placed those values, then you can balance the rest by inspection. So let's take a look, and sorry about this, the formatting made this part a little bit blurry. So if we're taking a look, first assign your fixed numbers. So oxygen, is -2. Sulfur alone is 0. Iron alone is 0. Oxygen is still -2. Going and filling in those missing atoms, so looking at the iron 2O3, this has a total net charge of 0. So -2 times 3 is 6. And so we have to have, or -6. So we have to split that in a positive value between two atoms. So we'd have +3, because +3 times 2 is +6. And now it's all neutralized. On the sulfur is with oxygen. There are 2 of them. So that would be -4. So sulfur has to be +4 to add to become a neutral atom. So now we're taking a look at what's changing. So sulfur is changing from 0 to 4. So that's an exchange of 4 electrons. And iron is changing from 3 to 0. So that's an exchange of 3 electrons. Now, before you take a look at balancing this out, you want to know how many atoms there are. And so iron has 2 atoms, so each of these would exchange 3 electrons. So that's a total of 6. Sulfur, there's no subscript, so it's still just 4. Now to make these the same, we're going to figure out our lowest common denominator, which would be 12. And to get that, we have to multiply the sulfur by 3 and the iron by 2. So these are the numbers so that we get that total of 12 electrons being exchanged. And to make them the same, we'll put the 2 in front of the iron oxide, and we'll put the 3 in front of the sulfur. So when we're doing this, all of this information is based on our reactants. Products just help us see what's happening. Then after that, we need to balance the rest. So we'll put a 3 in front of the sulfur. So now we have 3 sulfur on each side. We'll need a 4 in front of the iron. And then we just need to double check oxygen and it's balanced. So now we're done. Your coefficients were 2, 3, 4, and 3. Looking at our next example, similar start, assign your oxidation numbers. So hydrogen is always +1 unless directly bonded to a metal. That would give us a net charge of +3. So nitrogen has to be -3. Oxygen is 0. On the other side, oxygen -2. Nitrogen has to be +2. So I'm always starting with my fixed numbers and then figuring out the rest. So now I want to take a look. Oxygen is changing from 0 to -2, and it wouldn't matter if you brought it to the NO's oxygen or the water's. Either way, we have that same exchange. So that's an exchange of 2 electrons. And then that subscript, there are 2 atoms. So that's a total of 4 electrons that would be exchanged. Now, on the other hand, we have nitrogen going from -3 to +2. That's an exchange of 5 electrons, and there's no subscript, so that's just 5 total. So now lowest common denominator, we'll multiply the NH3 by 4, and we'll multiply the oxygen by 5. So that gives us a total exchange of 20 electrons. So we'll put the 5 in front of the O2 and the 4 in front of nitrogen, and then balance the rest by inspection. So 4 nitrogen on the left-hand side would give you 4 nitrogen on the right-hand side. And then we just need to work about the oxygens. So we have 12 hydrogens on the right. Put a 6 here. Will that balance this out? And that works. So now we'll have 10 oxygen on each side. So when you're done, your coefficients are 4, 5, 4, and 6. So always start with those fixed numbers, figure out how we're changing our OA and our RA, fill in those numbers, and balance the rest by inspection. Now, I just added this question in here about balancing in acidic conditions. And there is a way to balance with your oxidation numbers, adding in the water, adding in hydrogen. But I like to split it into 2 half reactions and balance that way. So I just wanted to show one other way of doing this problem. So when you're balancing in acidic conditions, if you're going to do half reactions, you figure out what's related in the question. And if they did have some hydrogens or waters written in, just ignore that because we're going to add that in. So let's start with the simpler of the 2 reactions, and that would be zinc turning into zinc 2 positive. So your rules for acidic conditions is you balance anything that is not oxygen or hydrogen. So we're already balanced. Then you add in oxygens and hydrogens if you have them to balance them out, which we don't. And then lastly, you add in electrons to balance out charges. So we'll need 2 electrons here, so we have a net charge of 0 on each side. Now moving on to the next half reaction, you have NO3 negative, and that's turning into NH4 positive. So nitrogen's already balanced. We'll move on to oxygen. We're going to add 3 water molecules to the left-hand or right-hand side so that we have 3 oxygens on each side. Then we're going to add hydrogen ions to the reactant side. From the NH4, you have 4 hydrogens. From the water, you have 6. So that would be a total of 10. So to balance that out, I need 10 hydrogens on my reactant side. Now I'm worried about my charges. So on my right-hand side, I have a net charge of +1. And on my left-hand side, I have a net charge of +9. So to make this the same, I'm going to add in 8 electrons to the left-hand side. And now I have a net charge of +1 on each side. So with your charges, just remember that you want it to be the same on each side. They don't need to equal 0. They just have to be the same. Now, before I add these 2 together, I have to multiply that first half reaction by 4 because it's about the exchange and balancing of electrons. So before I add this, I need my electrons to be the same. So let's write that out. You'll have zinc solid plus, and now I'm just adding my reactions together. So all of my reactants on one side. So +8 electrons plus 10 hydrogens plus NO3 negative. And that will move me to my products. And I have, oh, sorry, that 4 meant I had 4 zinc. And so on this side, I have 4 zinc ions plus 8 electrons plus NH4 positive plus 3 water molecules. So we're almost there. Your last step with this part is you cancel out anything you can that is the same on both sides, or reduce what you can. So what we can cancel is just the electrons, and that leaves us with our reaction, which you could write out one more time just to make it nice, but that is our balanced equation in acidic conditions. So if you found this helpful, please like and subscribe to this channel. That would be great. And if you would like me to do any video, please just leave me a comment. Thank you. Did you laugh at me? What? Oh, it's still